All right, let's continue our review of derivatives. And today we're going to look at the derivatives of exponential and logarithmic functions. So remember that an exponential function looks like f of x equals maybe some constant e to the kx. All right. So in this case, the variable is in the exponent, right? We have a variable exponent and a constant base. All right. So be careful because power functions also have exponents, but the exponent is a constant for a power function. Here, the exponent is the variable. So make sure you recognize the difference between an exponential function and a power function. All right. Now the other way we can write an exponential function is this way. We can write it as a b to the x. All right. So I'm only giving you the derivative of the function for an exponential function with a base of e. So if you need to take the derivative of an exponential function where we have some base other than e, we have to rewrite this. And if you remember, in this case, we have to rewrite this b as e to the k, right? So we have b is equal to e to the k, and then we can solve for k, right? So we can take the natural log of both sides, and we end up with k is equal to the natural log of b, all right? So just be aware of that. I don't actually think I have any examples in here. I should have included some examples like that. But primarily in this class, we're going to be looking at exponential functions with a base of e because it's so much easier then. Right. So, all right, let's take a look at this. Okay, I guess I mentioned we're also taking the derivative of looking at the derivative of natural logs. Now, this comes from chapter 7. We talked a little bit about the derivative of the natural log function, and it's just 1 over x. Okay, so we're just going to be using those two things today. All right, so this first function is e to the 7x. So here our k is equal to 7, right? So it's an exponential function because the variable is in the exponent. So be careful, like I said before, don't get it mixed up with the power function. So the derivative of this function, what we do is we just bring down that 7, not the 7x, just the 7, and then we leave the e to the 7x, right? So you don't subtract 1 or anything like that, all right? So read that carefully, what it says. We just bring down the k, and then we leave the e to the kx, all right? Next one. Here, the k is equal to a -1, right? Because negative x is the same as -1 times x, all right? So our k is -1. So the derivative of this function is we're going to just bring down that -1. So I could write -1, or I could just write negative of e to the minus x, right? So you leave this the same, the e to the minus x part. You just bring down the k and multiply. All right, let's take a look at the next couple. So this next one, our k is equal to 1/2, right? Because x over 2 is the same as 1/2 times x, right? So we have the k is 1/2, and so h prime of x is just going to be 1/2 times e to the x over 2. And that's it. All right, so here we have a constant multiple of an exponential function. So you just have to remember that the derivative of a constant multiple of a function is the constant multiple times the derivative. All right, so we're going to find dy dx, and we're going to leave the 5, and then we're going to bring down the k. So here k is equal to a -0.1. So we're going to take that times -0.1, and then times e to the -0.1x. All right, now I could rewrite that, or maybe you write it this way to begin with. 5 times the -0.1 is just going to be a -0.5 e to the -0.1x. All right, one thing I might note too, this is again another just a format issue. When you write decimals that have, it's where they're less than 1. So we have a 0 point something. It's always best to write, 0.5 and not 0.5, just because that point is very small. And so sometimes it gets lost and it matters, right? So that's why I always put a 0.5, right? And you have to be careful too not to make it too high. Oops, didn't mean to do that. I meant to just erase. I don't know if I can do it. Well, I'll write it. Make sure the decimal looks like a decimal and not times, right? So, in general, I would always put when you have a number like 0. Or like 0.5, write it at 0.5 so that it's clear what you meant. All right. Let's take a look at this next one. All right, I'm going to rewrite that square root of e. Well, actually, no, I don't even need to, right? I could write it as e to the 1/2, but there's no variable there. So this is just a constant. All right, and we know how to treat the derivative of a constant. The derivative of a constant is 0, so this the derivative of this function, so the derivative of the square root of e is 0, right? Because it's just a constant, and then derivative of natural log of x is just 1 over x. All right, let's take a look at this next one. Okay, now we have the square root of e to the x. So remember, we can treat the square root as a 1/2 power. So this is e to the x to the 1/2 power, and that is just e to the x over 2, right? 1/2 times x. And then we have times, or minus 5 times the natural log of x, right? So it's just a constant multiple of the natural log of x. So the derivative of that function is then, so this is 1/2 times x. So I'm going to bring down the 1/2, and then e to the x over 2. And then we have a constant multiple of the natural log. So this is just going to be 5 times 1 over x, or I could write it as 5 over x. All right. So let's take a look at the next one. We have the quotient. So remember that we can't just take the derivative of each part. So the derivative of a quotient is not the quotient of the derivatives. Be careful. Do not do that. We have to simplify this. So I'm going to use my rules for exponents, and I'm just going to subtract those. Since I have the same base, I can subtract the exponents. So this is really the same as e to the 4x. Okay. And so now I can find the derivative, dr dx is just going to be 4e to the 4x. Right? Just bring down the k. K is 4. And then times e to the 4x. All right. So this looks a little different. We know the derivative of the natural log of x is 1 over x. But this is not the natural log of x. This is the natural log of 10x. Now you cannot just replace x with 10x and say that the derivative is 1 over 10x. No. We're going to use the properties of logarithms, and this is a product, right? So the log of a product can be written as a sum. So this is the same as the natural log of 10 plus the natural log of x. All right. Now the natural log of 10 is just a constant. This is a constant. So g prime of x, right? The natural log of 10 is 0, and then the natural log of 1 over x is natural log of what am I saying? Derivative of natural log of x is 1 over x. So this is just 1 over x. All right. So be careful about that. We're going to learn something called the chain rule. That's coming up, where we can take, this is really the composition of functions. We have natural log on the outside, and it has a 10x inside of it. So it's really the composition of two functions, and we're going to learn something called the chain rule to be able to do that. But we don't actually need that here, because we can use the properties of logarithms and separate those two things out into the natural log of 10 natural log of 10 plus the natural log of x, and then take the derivative. All right, well, that's it. I'll let you work on the discussion questions, and I'll see you in class.